Hello everyone, in this lesson we are going to learn about resistors in series and in parallel. So first we will talk about how do we construct a circuit. So we use it using circuit diagrams. So if I draw something like this is a symbol for a conductor or a wire. If you see something like this is a resistor, and here is a battery or voltage source. So this battery or voltage source must have a terminal. So one having the shorter end to be the low potential, and the positive terminal would be the one with the longer vertical line. So let's try to solve a simple circuit using these three circuit elements. So we have a battery, a wire, and a resistor. So say this battery provides 18 volts of potential difference. So here we have low and high. And this resistor has resistance of 6 ohms. So let's try to ask what is the current in this circuit. And moreover, what is the direction of this current? So recall previously that when we talked about currents, we said that they flow from high potential, a flow of positive charges from high potential to low potential. So sort of like when you have here the ground in earth, and you lift this, say a ball, you lift this ball up, and what you observe to be the current or the flow from high to low potential is the ball that will eventually go down. So that is the analogy of our current. But now in circuits, these positive charges are actually sitting around in low potential. So in order for it to go from low to high, in order for this ball to go from this position to that position, something must push it up. So for example, that something is you. You need to place the ball into a high potential so that current will be observed as it goes down from high to low. So this element inside the circuit is the battery. So this battery, what it does is it traces not electrons. It traces the positive charges from low to high potentials. So for example, this positive charge is sitting in at, let's say it has a potential of 0 volts. And if it encounters a battery, what this battery does in relation to you lifting up a ball, this battery lifts up this positive charge by 18 volts. So now that this battery is lifted up 18 volts, Yeah. So now that this battery is lifted up 18 volts in this region, so it now carries 18 volts of electric potential energy. So now it has a high potential energy. And now this current, which is the flow from high to low potential, will naturally cause this battery to flow into a low potential. So this battery wants to go into a lower state of energy. And what it does is, when it encounters this resistor, sorry, this will cause to consume its energy. So when it's now here, uh, this originally 18 volts of electric potential in the battery will be consumed inside this resistor. So this positive charge carrier now will be in a state of low potential. So it will be driven again up to this point, and once it reaches this point, it will be again raised by this battery, and it's now in a high potential, and that's how a current flows inside a circuit. So this answers the question, what is the direction of current flow inside a circuit. So when you have a battery and you want to know the direction of the current, you simply observe the terminal. So you have here low and high, and what is the battery does is it pushes positive charges from low to high potentials. So the current flow will be around like this. So take note, what the battery does is push the current from low to high potential, but current always flows from high to low potential. So it always wants to minimize its potential energy. And what the battery does is, what the battery does is to push the charges from low to high so that it can flow from high to low. So that's the direction of the current flow. And now what is the magnitude of the current? So we will be using Ohm's law. V equals IR, and current is, we have 18 volts, or V over R, 18 volts over a 6 ohm resistor. So we will have 3 amperes that will be flowing inside this circuit.